So the figure shows triangle ABC inscribed in circle D. When they call it circle D and they use that letter, that tells us that D is the center of the circle. So C, B, D, this angle here is 44 degrees. They want us to find BAC, this one here. Okay? So we're going to have to do some legwork to get there. If this is 44, this triangle here is isosceles because D to B is a radius and D to C is a radius, correct? Oh, yeah. So that means that angle C is also 44 degrees. Therefore, 180 minus 88, because 44 plus 44 is 88, means that angle D is 92 degrees. Okay? And then angle D is a central angle creating arc BC. You may notice that ABD is an inscribed angle, also intersecting and creating arc BC. So if this is 92, this arc is 92, and if you remember, the relationship for an inscribed angle is that the inscribed angle is 1/2 the measure in degrees of the arc. So if this arc is 92, 1/2 of 92 is 46. Okay? That's 44 degrees, sorry. I started using the degree symbol to differentiate when I'm talking radians versus degrees. There you go. Hazlitt.
And the EOC will like the correct measurements count.
What do you mean correct measurements? Then you don't have to put it in degrees.
Oh.
You don't have to say 44 degrees. You can say 44. Okay. Okay, we got that one?
Yeah.
Okay. Moving on to 28. Oh, yeah, we got a whole story here. Love these stories. I'm going to sit. An archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. To assist the team, a robotic probe is used remotely. The probe travels approximately 3,900 meters at an angle of depression of 67.4 degrees from the team ship on the ocean surface to the sunken vessel. So the probe is going down an angle, and the angle is 3,900. The figure represents the team ship and the probe. How many meters below the surface of the ocean will the probe be when it reaches the ocean floor? So even though it's 3,900 meters from the boat, how far it is from the ocean floor is basically the straight up and down. Correct? Oh, okay. So it's, okay, so that's why. So some people are like, I had no idea like what they're talking about. That's what they're saying there. Yes.
I did it slightly different. I did a triangle like this.
Yeah, because they'll be
And I
congruent.
just found that angle by subtracting 90 by the angle.
So what David's saying is he did it over here, and then found this angle by subtracting from 90, which would work because 90 minus 67.4 is what?
22.6.
Which would be this angle here.
Yes.
You basically just made a congruent triangle, so that works. So what we're saying is if you do it this way, that's
I still
fine
got the
also.
right answer.
Okay. So when I'm doing it this way, though, I want to find that. So for a moment, this represents, and we have a 67.4 degree angle, right? Does that represent the side opposite, adjacent, or the hypotenuse?
X is opposite to that.
It's actually the opposite because your right angle is here. Okay? So it's actually opposite, and 3,900 is your hypotenuse. So opposite over hypotenuse is
So sine.
sine.
Oh, yeah.
Okay, you're gonna have to hold on, David. You did it back, which is fine.
Oh,
You
yeah,
did,
I did it
because you did
backwards.
cosine of the other angle.
Oh, yeah.
Okay? Okay. So in your calculators, if you do 67.4 sine times 3,900, I believe you get 3,600. Yeah. Okay. So that's why the answer is 3,600. David did it
Yeah, and I still got 36.
right, because you did this. And what was that angle measure there?
22.6, and then the cosine of that.
Okay. And guys, this comes up in other questions in the packet. The cosine of one acute angle and the sine of the other are equal. Because if you think about it, cosine means adjacent over hypotenuse. What is adjacent to one side, to one angle, is actually opposite the other, correct? Let's just think here. If I have this angle here, this is the adjacent, right? But if I'm dealing with this angle here, this side, if I'm talking about that, is the opposite. So there's a relationship there, which actually we discuss more in the first section. I think it's like question 5, where it literally says like sine of C and cosine of C. We'll go through that one. Okay, well, that's how we get 3,600. Oh, I see
It
where
was
the...
number 7.
Okay, yeah, no. Somebody was asking me a question earlier, and we weren't sure what question they were talking about, but now I see it's the next question. So the equation blah, 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 describes a circle. Determine the y-coordinate of the center of the circle. So I need to be able to complete the square. So I'm going to move these around. The x squared minus the 4x, those terms go together, right? Y squared plus 2y equals b. Now, all they really want to know here is the y coordinate. So remember, the format is x minus h, quantity squared, plus y minus k, quantity squared, equals the radius squared. So I really don't care about this part over here, right, in this case, because I only need the y coordinate. So I need to complete the square, y squared plus 2y. How do I complete the square? Half of the b term, so half of 2 squared, plus what? So that's going to become y plus 1 quantity squared, right? But the default is negative. So y plus 1 means the y coordinate of the center is at negative 1. If they asked for the x coordinate, I'm going to take the part that would help me with the x coordinate. X squared minus 4x. You take half of the b term, what's half of negative 4? Negative 2, and you square it. 4. And when you put that into parentheses, it's x plus 2 quantity squared, right? So the center of the circle would actually be negative 2, negative 1. Am I wrong, Karina? Did I do something wrong?
I think you did.
Yeah.
Because I got
It's
x
minus 2. Yeah.
quantity squared.
Oh, you're right. You're right. Yes. Because half of the b, you're right. Thank you.
So then it would be
So it'd be 2, negative 1. Yeah. Thanks for coming to visit, Karina. What?
I said, well, hey, Karina's there.
Do you have a chair, Karina?
I'm okay. There's one right here.
There's an extra chair. That's why I was asking. She's okay. We're not sure what she's sitting on, but she's okay. Shh, okay. Number 30. Triangle ABC is graphed now. So even though this drawing is bad, it's supposed to be a triangle. And they have the coordinates all mapped out for you. If triangle ABC is reflected over the line y equals 1. So the A coordinate isn't going to change, correct? The C coordinate is going to be down here somewhere, correct? And the B coordinate is going to be like over here somewhere, right? And I don't really care exactly where they are because they just want to know what quadrant will not contain any of the vertices. So that's quadrant Roman numeral dos.
Wait, can you just write 2? Or
Yep.
do you have to do it in the other one?
No, you can just write 2. Yes.
So the A does not change because it's on the line.
Correct.
So it's stay there.
Correct. Anything when you're reflecting, rotating, dilating, if it's on the line or like when you're dilating or rotating, if it's the point of dilation or the point of rotation, it won't change.
In the SSA, like, would there be a thing where I can use Roman numerals, or should I just like write 2 or like 2 eyes?
Honestly, I think that would probably be like drag and drop.
No.
I would just use 2 or 2 eyes. I don't think they would ask a question that had a Roman numeral like that. I think they would even accept, well, you probably can't spell out TWO because they lock which keys you can use. If you've ever tried to like
Yeah.
type in the
Yeah,
wrong
but
key,
considering there's only 4 quadrants, they would probably just like.
yeah. They could put something like put a dot in the quadrant that has no vertices and then you would just put a
like
dot
select the one.
any quadrant.
Oh, it makes you like draw them.
Okay. Okay. 31. Okay, this is supposed to be Colorado.
Well, it does look
Okay?
like
Okay, now, they want the permit now. Guys, this is what I want you to make sure you understand. Where it says 2.76 in hundreds of miles, that means it's 276 miles. 3.87 in hundreds of miles is 387. Basically, you're taking that number and turning it into, your hundreds is moving it 2 decimal spaces. So 276 plus 387 plus 276 plus 387 is 1,326. I'm assuming we all got that.
wait.
I'm waiting.
That's really how big is that really how big Colorado is?
Google it, but yes.
Accurate.
Oh, you can't do it.
So yeah, if you actually like happen to know, oh yeah, Colorado is 1,000, you can Google it on your phone.
1,000.
Actually do it this way. What's 387 times 276?
A number.
Yeah, what is it? That'll be the area of Colorado. Google it. What's the area of Colorado? See how accurate it is. What?
106,812.
That's okay. So Google, what is the area?
104,000.
Well, so it's pretty darn close.
Yeah, it is.
Maybe it's really a trapezoid in real life.
Actually, it is like a rectangle, but like there's curves.
See, there's a few curves in the rectangle.
Yeah.
Okay, great.
It's very rectangular.
Good job.
I think Wyoming is one.
Okay, Wyoming is okay. Moving on.
Wyoming and Colorado were
Why are we talking about this?
Okay, we are.
Wyoming is a concave, removes-
The figure shows a circle with center P and diameter of BD. An inscribed triangle BCD. Why are you waving that in front of my projector?
He likes moving industrial.
I mean, look at it.
Cool.
Do you understand why that would make me nervous, Alan?
Yeah.
Because the results of this EOC mean way more to me than they
So what
do
happens
to
if we all
you.
fail?
I
They have
will
to
quit.
move.
I would die.
Oh, no,
They won't care because
They won't
everyone
fire
fails.
me.
Then
I will be mortified, and I will say I suck as a teacher.
What if we
and
all get
will-
three?
I will probably quit.
That's so sad.
No, what if 20% get 3?
What if about 50% get the shit? Liars.
Then 50% get a 2.
Wonder if everyone's had those, then everyone better grades.
Those are a lot of stickers.
Yeah, but this is all video, so if a parent says, like, why is my child not doing well, and I, like, can play, I think your mom will recognize your voices.
Mom? My dad
Probably
watches
watch
the
it
videos
with
with
my
me.
That's why I haven't
I'm
said
on.
anything.
Hi, Mom.
Hey, Dad.
How about we actually do some math?
Alright, let's do math.
Okay, the figure shows a circle. So we said the length of P to C is 10. That means the length of B to P is 10 also, correct?
Yes.
Because that's a radius, right? And that's a radius, okay? Let angle B, C, okay, I'm sorry, C, B, D is X, correct?
Yes.
And B, C, D is X plus 54. Okay. Sure. Eddie said he's supposed to go to bigger 6th period. I don't know. I can't remember.
No. Why did you have to say that? Now I'm gonna be annoyed for the next hour because I'm not gonna remember.
Marco, go to 8th grade office for a minute.
I won't ask you a question.
Okay, shh, guys. This is X. B, C, D is X plus 54. Shh. By the way, if B, C, D, does anybody know what the actual measure of B, C, D has to be?
54, because the
B,
angles need to be.
C, D.
90.
90. Why?
Because the triangle is inscribed.
Okay, it's, okay, we're gonna stop talking over here or we're going to leave class. BCD has to be a right angle because it's a triangle inscribed in a circle and the hypotenuse, the longest side there, is a diameter. They use that a lot, so, and as we go through this, you keep seeing that happen a lot.
Can you put definition of inscribed triangle, reason why?
Nobody's asking you to give a reason why.
I know, but can that be a reason why we use in the future?
Sure,
So you
just sure.
So you would just take 90 and subtract.
Okay, guys, stop talking and listen. This is an inscribed triangle, correct? If you have a triangle inscribed in a circle and one side of the triangle is the diameter, then that triangle is a right triangle and that diameter is also the hypotenuse. We learned this in chapter 10. So angle BCD has to be 90. And they tell you that BCD, which has to be 90, is equal to X plus 54. So how are you going to solve for X? Minus, excuse me. So you get 36. Did you need to know that this was 10? No. Once they told you that this was the diameter, they could have just given you the X. The 10s don't mean anything. Okay? Number 33. Again, we have kind of that same drawing there, right? Actually, that exact same drawing. 10, 10. This is 10, right? This is X. We just said BCD is X plus 54. So we know that X is equal to 36. Okay? So choose yes or no for each statement. The length of CD is less than 10. We don't know what the length of CD is, do we? Okay? Okay? And it's not 10. The length of CD is greater than 10. How do we know that the length of CD, that is true. How do we know the length of CD is greater than 10? If we go back and finish filling this in, we would get that angle C, this angle C, PCD, is 54. This would also be 54, correct?
Yes, because that's isosceles.
Another
Isosceles. and this one's 72. So the side opposite the 72 has to be longer than the side opposite the 54. So you follow how I know that CD had to be longer than 10? Okay. How do I know that triangle CPD is not equilateral?
Okay.
Yeah.
Because the two sides are radius.
Well, but how? Okay, but if these are 10. Look at the angles. In an equilateral triangle, all the angles would be how many degrees? 60. The measure of CPD, we actually figured it out. What's the measure of CPD? What's the measure of CPD? 72. So it's not less than 60. Why is it what?
Like just
Which one are you confused about?
all of them.
Okay. Okay, look here. Look at this triangle. Here, maybe it'll help if I draw it like this. Just so you just have that triangle. This is C, this is P, this is D. This is 10, this is 10. This angle is 54 degrees. This angle is 54 degrees. This angle is 72. Okay? So the side opposite the 72 is going to be greater than the side opposite the 54. Okay? And the measure of CPD we found is 72. That's greater than 60. Okay. For number 34.
This fall.
Yes.
For an equilateral triangle, all the interior angles are congruent, right?
Correct. And so they're all 60 degrees because that's the only way to have them all add up to 180 degrees.
Oh.
Okay. Number 34. The figure shows the results of a geometric construction. The first step of the construction is to draw an arc centered at point A that passes through points B and C. So when you do that, what do you actually create? You actually create this is congruent to this. Ultimately, we're creating angle bisectors. But when you do this, you haven't done any of this part yet. Why are you doing that? Because you're creating 2 points equidistant from A. So the answer is AB is congruent to AC. And look at your other choices. AB and BC, like we don't even have a line there drawn to BC. AD, well, they said the first step. And BD, again, D is in the second step. The first step just deals with points A, B, and C. Okay, do we get 34? 35. I think we're using that same drawing again. The construction actually could go on to create congruent triangles, ABD and ACD. They didn't show that, right? But I could draw congruent triangles there. Which statement provides evidence that AD is an angle bisector of BAC? Well, if D is a bisector, then BAD would be congruent to CAD, correct? And that's why it's C. Okay. Okay, number 36. Okay, a steel pipe is in the shape of a right circular cylinder and is used for drainage under the road. The length of the pipe is 12 feet long and its diameter is 36 inches. 36 inches is how many feet? 3. How many square feet of steel is the outer surface of the pipe? So basically, this is kind of like the problem you had on the USA test prep on the Chapter 11 test that talked about a cylindrical shaped dog pen, do you remember? It says something about you're building a pen for your dogs, and it's in the shape of a cylinder with an open top. So I know if you're watching the video, you can't see this on the video. But basically, this was our cylinder, right? Now you're building a dog pen, so you don't need the circle on the top. And you're building a dog pen. Like when you fence your backyard, you don't put fencing along, like it touches the grass, but you don't lay fencing out on the ground, right? Because the dog's on the ground. So basically, when you open up that cylinder, you just have a rectangle. That's the same thing that's happening with this pipe, okay? Although it would make more sense that the pipe is kind of like this. This is the 12 feet, and this is the 3 feet, and I roll it up. So when I unroll it, I have a cylinder that has a circumference of 6 pi, right? 3 times 2, 3 is the diameter, right?
Yes.
So sorry, 3 pi. And they wanted this rounded to the nearest integer. What is 3 times 3.14?
About
9.42.
And then times 12.
113.
113.04, they said round to the nearest integer. Question?
Yes, I didn't realize that it said 36 inches. So the entire time while I was doing it, I got 113 as the circumference of it, and when I checked the answer, I thought there was a typo in the
Yes,
question
no.
that it was asking for the circumference.
No, guys, I would hope typically, when you have standardized tests, when one thing is in feet and one thing is in inches, they kind of bold it to bring it to your attention. But pay attention to that. You see that a lot in this practice of things being given in some in feet and some in inches. Yes.
Wait, I don't understand this.
Okay. Do you get? This is my pipe, right? It's 3 feet long, right?
Right.
If I rolled this up, I really want it to roll. I'm going to roll it because really it should look like this.
That would be 12.
If I roll it up like this, right? So if the diameter of this is 3, when I unroll it, the circumference of the circle becomes the length of the rectangle, right? So this formula for circumference of a circle is 2 pi times the radius. So that's the end. And then the pipe is 12 feet long. Okay, they told us though, and I will tell you, when I did the problem, I made a mistake and I used 6 pi because I was thinking that 3 was the radius. 3 is the diameter. So the radius is actually 1.5, right? But we don't need to know that. So the diameter times pi, so basically 3 times 3.14, which we decided was what?
9.42.
Something.
42.
That's the circumference of the circle, which becomes the one dimension of this pipe when we unroll it. Because when we have something rolled up as a cylinder, when we unroll it, it's a rectangle. Okay? So that times, does that make sense? Because 12 was the length of the pipe. Does that make sense now?
Yes.
Are you sure?
Yeah.
It was a little bit more convincing a few sentences ago.
I just need to think about it.
Okay, think about it. Think about it for a second. Okay. Now we have a steel pipe again. Now, it's used for drainage. The length of the pipe is 12 feet and the diameter is 3 feet. The pipe is open at both ends. A wire screen in the shape of a square is attached at one end of the pipe to allow water to flow through and keep it. Okay, so the water can still go through, but the animals can't get in because this part is all open, but the animals aren't big enough to get in there.
Yeah.
Okay, so if the diameter, that's the diameter, right?
Yes.
And that's 3, correct? What is the area and the perimeter of the screen? Okay, so Oh, ooh, there's two ways to do this.
Yeah.
No, I'm not gonna teach you a new way. Yes.
Wait, so I found that with this, you can either split it up into 2 or even 4 right triangles.
Okay, but you can do that, or you can just find the length
Oh,
of the side there. Okay, so guys, here's what I'm gonna do.
'cause I split it up into 2 right triangles and then I used
Okay,
the
can
hotel.
I actually teach? Oops. So, this would be the right angle here. This is what I'm talking about. This is 3. Since this is in a square, this is 90. When this gets cut in half, this is 45 and 45, correct? So this is a 45-degree angle. And this is a 45-degree angle. Okay? So, and this is a 90. So we had rules. The side opposite the 45 would be x, right? And the side opposite the 90 would be x radical 3. Really have x radical 2, sorry. Thanks. So what we're saying is if we want to find the side length here, I need to take x radical 2 and set it equal to 3, correct? So basically, I'm going to do 3 divided by radical 2. So I'm going to get my calculator. What is radical 2? It's about 1.4.
1.4142.
1.412.
1.4142.
1.4142? Okay, I like that. So I'm going to divide 3 divided by 1.412, and I get 2.12. Correct?
Miss Hall,
Yeah?
it's like not important. I just wanted to add that I did it a different way and it was really close. But it was wrong.
But it was wrong.
I got 2.25 doing it a different way, but it's just close. I'm just saying.
Okay, well, we're not getting the right answer here anyway, are we? What did I do wrong?
I did inches instead of feet.
And was inches right?
Yeah.
Okay, that is I had a problem on this one because my feeling was it doesn't say whether they wanted it inches or feet. So we want to do inches? I'm gonna like that better. Okay, take 2. 36 inches, right? So x radical 2 equals 36. 36 divided by basically 1.4 is 25.7. And 25.7 times 25.7 I get is roughly about 661. Is that what you guys had?
For the area?
The area I got 648 inches.
Yeah, that's what I did it a different way.
Okay, what'd you do, Jose Luis?
I-
Because what I'm doing is I'm finding the length of this is 25.7, right?
Yeah.
And then 25.7 times 25.7 would give me the area, right?
I found the area of like half of the triangle and then multiply
Okay,
that
so wait,
by
what
2.
did you do?
I found the area of half of the square.
So this,
That would be 18 because that's the radius. So
okay.
And then the other one.
Oh,
I
okay,
did
so 18.
times 36 divided by 2.
Okay. Okay, I think what I'm getting is I'm getting a rounding issue because I'm dividing by 2. You understand what I'm trying to do here?
Yeah.
Okay. So you did it that way. And then you got 648. Okay. The other thing you can do if you want another one to do. Do you want another one to do? Okay. You can also use this to find the area of rhombuses. We don't teach it, but it's a nice little trick here. To find and a square counts as a rhombus, right? You can take the length of the 2 diagonals, multiply them together, and divide by 2. So each diagonal is 36, right?
Yeah.
So 36 times 36 is 1,296 divided by 2 is 648. That's what I did, but we didn't do that at all this year in the book or anything, so I didn't do it. That's what I did, and then I tried to go back, okay? So guys, if you want to, for any rhombus, this would also work for a kite. You can take the two diagonals, multiply them, and then divide by 2.
Miss,
Yes.
if you split the square into like triangles, wouldn't it be like 18 and 18 and not 18 times 36? Why do you multiply by 36?
Base times height divided by 2.
But
You're
if
trying
you
to find
do
the area of the square.
Oh.
Base
okay,
times
okay.
height divided by 2, and
I
there's
thought we were
2.
doing, like the tiny triangle, like
Okay.
one of the triangles.
Okay. Now, what I would do for perimeter, if the area is 648, I would take the square root of that, which is 25.45. Remember, a minute ago I had something, I think I had like 25.47 when I was doing the 45, 45, 90. 25.45 times how many? 4. And I get about 101.8.
102.
Okay? So there's a few different ways you can do that. Actually, a lot of different ways. So you could do, so basically recap, what I really did when I did it was I did diagonal 1 times diagonal 2 divided by 2, but that's not a formula you guys have learned. Because I didn't feel like giving you another formula was really what you wanted. But I'm giving it to you now. Or you could break this into 2 triangles, and you could do the base times the height, find the area of the triangle. Or you could use what I was doing, which was a 45, 45, 90. But you're right, then you got I had a weird rounding issue. Okay. 38. An unmanned aerial vehicle, which is basically a drone, is equipped with cameras used to monitor forest fires. Okay? It's flying at an altitude of 1,000 meters. Moment in time, the angle of depression from the UAV to the fire is 30 degrees. That means this is, excuse me, burped. This level. Oh, my phone is ringing.
Phone is ringing.
Hello?
The video is still going.
Hello, YouTube.
When the bell rings, you are free to go. Okay. Shh, I'm not talking to you, but you're free to go also when the bell rings. Okay. Guys, if this is 30 degrees, this is 60, right? So we want to know, what is the distance from the drone to the fire? We are actually finding basically the hypotenuse. Okay? We have a 60-degree angle. We have the adjacent. We want to find the hypotenuse. That's cosine. Cosine 60 equals 1,000 over x. Okay? So you have to find the cosine of 60 in your calculator. And normally I would say to 4 decimal spaces, but it is 0.5. Okay? So 1,000 divided by 0.5 is 2,000. It's 1,000 feet, above the ground, but it is still 2,000 feet, meters, getting the wrong dimensions, 2,000 meters from the fire.
1,000 miles away.
I know, 1,000 meters away. You know, it's been a long day. Oh, it's another one.
But
There we go.
it's the same thing, but with a different
Alright.
line that you're finding.
Now we want to know, guys, same type of problem, but now we want to know how far it is from D to the fire.
So do the same thing, but with tangent.
So this is 1,000. Now you want to find the opposite, you have the adjacent. So tangent 60 equals opposite over 1,000. Okay? And I believe the tangent of 60, I think, is 0.8660. But whichever, no, it's not. I have something written wrong here. I have the right answer, but I don't know why I wrote 0.8660. I did something wrong. Okay, tangent of 60 times 1,000 is 1,732. Ooh, we have time and we can do our first spring one. Spring into action. Okay? So, spring is attached to support B at the other end of collar A. Basically, this to here is our right angle, right? Okay? The angle theta is the angle created as the collar moves between points C and D. Okay? If this is 28 degrees, and when it's straight across, it's 3 feet, what is the distance from A to B? So I'm finding the hypotenuse, right? So I have a 28 degree angle. I have adjacent over hypotenuse. That means I'm dealing with a cosine. Correct? So what is the cosine of 28? Is it 0.8829?
0.88295.
So I'm dealing with 3 divided by 0.8829. And I believe you get 3.4. Am I correct? Am I correct? Cool.
Yes.
Okay. Oh, let's do 41.
Another spring.
Another spring.
Oh boy.
Okay. So now, A to B is 5.2. So adjacent over hypotenuse. Since we're finding an angle measure, we're going to be using the inverse. Now, the button on your calculator, if you try to use the on-screen calculator on the EOC, will say arc cosine. It won't say, okay? It's just another way to write it. So instead of tangent -1, they'll say arc tan, arc sine, arc cos. 3 divided by 5.2, second button cosine. And you should get 54.8. And now we're going to take a break.